My name is Dan Anderson. I'm a principal architect for VMware. I've been with VMware coming up on my 7th year. And what this session is about, as you can see, there's no computers in front of you. This is not where you actually do stuff. You do that downstairs in front of the big orange banner. My job here was to actually architect the data centers for VMworld. They even talked about it a little bit this morning in the keynote. And we kind of, when I was going through all of the efforts and the trials and tribulations of what we were doing, we realized that there was a lot of key takeaways, not just from us doing this, but for our customers who are actually going down that path of doing external clouds, internal clouds, hybrid clouds, clouds. The journey. Okay? Virtual roads, actual clouds. That's all I'm going to mark. That's it. I'm not doing that anymore. Okay? But anyways, so we learned a lot of things because we do things a little differently than you do. You grow your data centers over years. I grow mine over weeks. Okay? You build yours over the course of a couple of years. I build mine over a couple of months. Last year, who was here last year? Hands? Anyone? See that data center down at the bottom of the escalator, right? Well, that data center was built in 2 months. It was put on trucks, shipped here, stood up, and supported the labs, albeit in somewhat of a dysfunctional manner, but it did support the labs nonetheless. You see the data center at the base of the escalator this year? No, you don't. First of all, I wanted to hide my equipment from you because you kept poking it and touching it. And the second was I wanted to put a couple of sections of it in actual cloud or actually out at colo facilities. So what you've got, thank you to all my friends and sponsors, because without the $20 million worth of gear and effort that we actually do, that's literally the cost of the gear that we've got, $20 million, 150 lab proctors, right? Time to develop the content and material, all of that stuff. These guys are responsible for providing a lot of. Terramark is one of the data centers. Verizon provides one of the data centers. NetApp, HP, EMC, Cisco, Intel, Kingston, MDS, Zego, and Mellanox all participated in giving me gear. So, my gear is free. So I have to do that. So, this is what it looks like. Believe it or not, when you go down and sit in the labs, that you're going to be sitting in the labs, and you're going to be taking a portion of those labs that are actually sitting in Terramark in Florida, in Miami, Florida, on the NAP of the Americas. And the second area where they're sitting is actually in Ashburn, Virginia, at the Verizon Colo facility. Now, we're backhauling. Now, we've had our fair share of issues and bumps, and that's just the way it is. So somebody asked me yesterday how we load test prior to VMworld. And I thought it was a pretty good question, and I answered it like this. Well, 4 days before VMworld, we start our load test, 3 days of which is actually building the data center. So on the 4th day, we load test. And on the 5th day, that's when y'all show up, is when we really load test. Okay? So if you wonder why Mondays are usually a little bumpy, it's because of that very reason. Because it's not very easy to test things like a pipe that runs from one end of the country to the other when you don't have it until 4 days before the event. And just remember, I got to set up all the data centers in order to actually be ready to test. So that's kind of our testing strategy, is we use you guys to test, and when you bitch and complain, we kind of fix whatever we see. Okay? So we had what comes out of this? Fundamentally, there's really a lot of lessons learned here that you guys, you as our customers, folks that are actually deploying clouds or actually dealing with this, are going to have to take away. And the first lesson that we took out of this, okay, was absolutely change control. When you're moving at 2 months to install 3 data centers, fully operational, and I'm not talking about standing up a few apps, I'm talking about being able to tear down and build over the course of 4 days. You probably heard it in the keynote this morning. We gave them conservative numbers. We're doing 3,700 labs a day at the current pace. Okay? And the average is we're going to tear down and build 100,000 VMs over the course of the next 4 days. Okay? We built the infrastructure to support that. But when you do that, okay, you got to do it fast. We got to do it fast, and we got to do it efficiently, and we got to make sure that Bob's that works in on this section is not screwing up what Rick is working on over here. There is no Bob and Rick. I changed the names to protect the innocent. So we just wanted to make sure, first and foremost, we needed change control. But we needed change control that could be as, change control, as everybody says change control, you start cringing, because, I'm fairly sure some of your environments have change control policies that are somewhat restrictive, I think is what the term is, right? Change control for us meant somebody not butting up against somebody else and breaking something. But we're lucky enough to have a core team that's small enough that we can actually have those conversations. Which leads me to number 2, communication. Change control, communication. So how we fixed that? We had a central project manager, not many. We had one central project manager who was the hub of the communication, and she was also the heart of our change control. Because I didn't want to build a big change control system, right? And of course that spikes off into how you actually do manipulate and change things, okay? Well, I'll talk a little bit more about that in a second. So, this is what the network looks like, sort of. We made some modifications over the course of the last 48 hours. Communication, I'm going to get to that one. So, I come from the unified messaging world. And I said, you know what? I want a dedicated 45 megabit pipe outbound, okay? And they gave me a dedicated 45 megabit pipe. And I said to the net, by the way, if you want to know the exact words. And they gave me a dedicated 45 megabit DSL pipe to the internet. That's not necessarily a point-to-point. Okay? It's kind of what I meant. It's not what I got. My boss, he ordered what I asked for, and we got what he asked for. So here we are. Vpn tunnels. We want to connect these sites with VPN tunnels. Making the decision to do things like flat networks. Do I want to do stretch layer 2? If you're going to build a VPN connection, what protocols do you need to run over it? I challenge any one of you out there to take a encrypted, compressed protocol and try to run it across an IPsec tunnel, especially if it's UDP. Let's see how well that works for you. We tried it. It didn't work too well for us. So we basically had to come up with another plan. And I'll get back to that in a minute. But the ability to be dynamic. A lot of you guys are going to be moving much slower than we were, granted. But these are lessons learned that you guys can all take heed of. Because if if you're going to build this, that's the question. What are you going to run over it? Right? What's going to be there? What applications are going to be running there? What do you need to do there? How do you need to, and by the way, here's the other big question. Right? If I need to build all of my templates at Verizon, okay, and we're talking about 2008, Server 2003, all of that stuff, right? XP VMs, View desktops, all of that. They all have templates. How are you going to move them? I'm not talking about nits here. I have 30 labs, okay? One of the differences between these labs and, say, anybody else's labs that might be an application-specific lab, these are systems labs. These are encapsulated 200 gigabyte chunks of data that I need to move, and I got 30 of them. Okay? And it's average, that's average. 200 gig is about the average size of a vPod. Now I got to get them from Ashburn, Virginia. Actually, where it all started was Cambridge. Then we actually got the colo sites, and we actually shipped gear to the colo sites. But we weren't ready to actually finish with the content. So we needed to get the content finished, and I needed to get it to 3 sites. Just remember that. If you're going to haul 2 terabytes, plan on enough time and enough bandwidth to meet your needs. Right? Because I'm going to tell you right now, smaller the bandwidth, the bigger the time. Smaller the bandwidth, the lower the cost. The higher the bandwidth, the lower the time. The higher the bandwidth, the higher the cost. Now, you'd think that would be intuitive. Okay? You think it's okay that on the normal operating day that you only need a DS3. But if you plan on hauling files that are 100 gig across the wire on a regular basis, you might want to rethink your strategy. Okay? Or you come up with an alternative. This is that whole kind of thinking outside of the cloud kind of thing. Box, excuse me. Sorry. Couldn't resist. So what we did was we actually got an iOmega and a body. And we flew them to Cambridge with 2 iOmegas. And we had a second body meet them there, and we copied all of our labs that needed to be actually moved into the actual lab spaces at Terramark as well as here in Moscone. We didn't stage it in Moscone. We staged it down at San Jose, in one of our facilities down in San Jose. But we literally copied or exported those labs, all 2 terabytes worth, and they literally got on planes, separate flights, carried that box with our data, got to the actual location, successful copy. Once that copy was successful, basically what we did was we put the other guy on another flight south to Miami and the other guy south to Miami, separate flights, and put those boxes on separate planes with those guys, and they did the copies. You notice that that was redundant, right? Very purposeful, okay? Because for us to do the exports of the lab took literally 6 days, okay? Now let me talk a little bit about Lab Cloud, because that's the interesting thing here. Lab Cloud, as you guys will see, when you sit down in front of these computers, or these thin clients, you're going to see this interface. All nice little click buttons. You pick your lab, you choose. It's got a timer. It's got automatically deploys your labs. All right, submits help, little help requests, and so on and so forth. Homegrown application by 2 guys that actually work for VMware. Not a product. Not ever planned to be a product, as far as I know. The 2 guys are actually on our cloud team. They actually, sorry, I had to say it again, but they actually are on our cloud team. They're out there, some of the field guys, cloud architects that actually work out in the field, Claire Roberts and Curtis Pope. They wrote this app to help us deliver these labs. It's based on a lab manager backend and is built against APIs with vCenter and various other components. So it's, as you guys are going to find out over the course of the coming days, cloud is not one application. Cloud is many applications, many systems coming together, multi-site, single site. It's that construct. It's a, VCD, I think they announced it today. It's one of the components that helps make successful cloud. It's not the cloud, okay? But anyways, wow, that was like 10 times in one. Wow, it's terrible. So the network, the core infrastructure here is 10 gig, okay? 8 site, 10 gig. Between us, not so much 10 gig. DS3s. I have a triangle, as I said. That previous slide basically showed a triangle. That's exactly what I've got. I get DS3s linking to sites. Okay? I would rather have point-to-point, and we're going to carry this over to VMworld Europe. So the same infrastructure is going to be used at VMworld Europe. We're going to backhaul from Copenhagen. That's why we put them on the East Coast. We're running somewhere around we're running about 100 milliseconds latency from here. And from Copenhagen, we've already tested through Colt, the provider that's going to be providing our systems. We've already tested and we're running it somewhere around 115 milliseconds latency from Copenhagen. So it's very important to understand that, right? Latencies are important to us. Again, these are things you need to think about. Where are you putting this? Why are you putting it there? Right? I put it on the East Coast because I knew I was going to reuse it again for Europe. All right? So I'm going to tear up the equipment here, ship it overseas, reconnect it over there, then backhaul. Now, what I did do is I specified I need 45 megabits, burstable to 100, point-to-point connections. And I got them, so I'm good. It's all cool. It doesn't really matter because I'm going to tell you how I fixed the other problems that I had. So, all connections are all the public internet. We're using IPsec VPN tunnels, as I said, sort of. We tried to run an encapsulated PCOIP stream through a VPN tunnel. We had some configuration issues on our router, our firewalls. I kept getting corrected as I was trying to fix problems on my firewalls. Kept calling them routers. They weren't routers, they were firewalls. But anyways, I had problems, couldn't get what I needed from a UDP perspective. So what ended up happening was we went to Teradici and went to our development community and we said, guys, listen, we got a problem, we can't do this. They said, we have this thing called a PCOIP gateway. I'm like, really? I never heard of it. It's news to me. Yeah, we're just kind of working on it. I said, well, how kind of working on it are you? And they said, well, it's alpha code. I said, well, how have you tested it? Well, we've run some simulated loads over it. I said, well, how many? And they said, well, 2. And I said, well, did it work? And they were like, yeah, it was awesome. I said, great. Give it to me. And they're like, no. So my boss picks up the phone and calls his boss and says, listen, we're at VMworld, because this was 2 days ago, by the way. It's Sunday, we're at VMworld, and I need your PCOIP gateway. Guy says, fine, no problem. Ships PCOIP gateway, we pull a couple of Teradici guys off the floor, put them in a laptop, we sit them down and say, work with him, get that running, because we're going to hump some packets over this thing over the course of the next 4 or 5 days. So that's exactly what we did. We bypassed the VPN completely. We're running a PCOIP gateway sitting on the public internet at Verizon. So we've got a public IP address that we can hit this thing from here. Okay? And interestingly enough, we're now concurrently running 130 sessions to each facility from here flawlessly. Matter of fact, we're chasing some problems right now on the local site. We're actually getting better performance out of our site that are remote than we are on the local stuff. I say better performance. Some of the labs are actually misbehaving. But lesson learned, right? Make sure you do your research. Make sure you understand what you need to do to traverse your packets, traverse your data. How are you going to move that data back and forth? Let's get to some of the stuff that we got here. I know you guys have had time to digest some of these slides. I like to leave them sitting up there so you can kind of look at them a little bit, because those numbers are kind of hard to fathom. All right? You remember last year, I don't know if you ever saw the building of the data center, the time-lapse photography. It's one of the coolest things ever. I have literally play that at least once a month just because. It just jazzes me up. But literally, the amount of work that we've done and the servers that we've got, 329 terabytes of raw storage, that's 1/4 of a petabyte, okay, spread throughout 3 locations. Servers, 352. Sockets, 736. Right? Now, when we say servers, I mean ESX hosts, okay? That's ESX hosts. We don't have anything that doesn't run in a VM. If it doesn't run in a VM, it doesn't run here, unless it's a gateway appliance, a firewall, a switch, or something along that lines, okay? It all runs. If it's a server, we're considering a server to be an ESX. 736 sockets, 3,072 cores, 7.5 terahertz of computing power. I just like to say terahertz because it's kind of cool. 14.6 terabytes of memory in these servers. 480 PCOIP-enabled 0 clients. That's the menu. So when you go downstairs, at any given time, you can run 480 labs, pick from 30. We can do 22,000 hours of content this week. Okay, that means that if you want to sit down and take a lab, and you wanted to take all 30 labs, you would have to sit there 4 days in a row for 8 hours a day to take all 30 labs and all the content that we've got. That's a huge amount of effort, right? I didn't focus on any of the content this year. I focused on actually delivering it. So, you know, those guys, we have 30 teams of 2 guys, lab captain from the States, and a lab captain from overseas. Could be EMEA, Asia Pac, ANZ. We brought them all together. They're all here. So there's 2 individuals who are specifically SMEs, developed the content. And then we've got 150 people out on the floor answering questions and supporting, grouped into groups of 6. Based on the actual, like it's like a desktop application or something like that, based on our target audience. 30 lab topics, 44 lab hours of time over 4 days, 400 lab seats, 22,070 if you want the exact numbers, okay? That's if we were 100% capacity, which we're not going to be. We're on target to be about, I would say, 15,000 hours based on our current numbers. So 4,000 VMs deployed and undeployed every hour, okay? Every hour. Now, for those of you that have like 2 or 3 VMs running on an ESX host, I know that might not mean much to you, but that's a lot. All right? Our goal is to have 12,500 plus labs completed, and they say they want to see 125,000 plus VMs deployed over 4 days. We'll see. We'll see what happens. But those are the fun facts, and that's that. So now let's talk about the verticals. So, whenever I go out and I do architecture, a lot of the questions come up are like, why'd you do this? Why'd you do that? So I want to talk a little bit about how we lay this stuff out. I always like to have a management cluster. Okay? And I know it's a little harder for those folks that have smaller instances and smaller environments. But even if you do, having a management cluster with a minimum of 2 or 3 hosts, ESX hosts, dedicated to house your virtual center, your SQLs, your Active Directories, things along that lines, pays big dividends if something goes horribly awry. Because I'm going to tell you right now, those of you that like to run big-ass clusters and you want to run 32 hosts in a cluster because we say that that's okay, okay? I've been batting around this term inside of product management and engineering lately over the last couple of 6 months when I've been hearing some of the numbers that they're talking about calling a supported configuration. And those words are operational prudence, okay? So, operational prudence. Running 150 VMs on one physical host. Is that operationally prudent? It is if you can fail it over effectively, but it may not be if you can't. And now, I love you guys, all of you, every one of you personally and on a professional basis, but you're getting greedy. It used to be, I remember, 4 years ago, 2-to-1 consolidation was considered exceptional. Remember those days? Now you're saying, hey, how come I can't do 50-to-1, 60-to-1? You can. But I'm going to throw the words operational prudence at you, okay, all day long. All right? So anyways, I like to have a management cluster because if you have a cluster of hosts that's 24 blades or 32 blades, and your vCenter's on there somewhere, and you happen to have some idiot that works at the that works in the that's somewhere that trips over a power cord and, or shorts something out because he plugs in a buffer or something like that into one of your racks, and you can't find your virtual center instance, and you need to bring up Active Directory, you need to bring up your DNS servers, you need to bring up all that stuff, and you have to look through when you have, how many terabytes of storage was it that I had? 14.5 terabytes, something like that? Oh, I'm sorry, that's right. It was 1/4 of a petabyte of storage that I need to look through to find my virtual center. Actually, in this case, there's only 32 hosts, but still, each host has a 5 terabyte volumes, multiple 5 terabyte volumes. Looking for that in a time of emergency is pretty difficult, okay? And you want to get stuff online, right? Severing your network connections. Everybody knows. Who's had the HA problem? Anybody? Oops. My network went away because I did some network maintenance and I forgot that I had HA enabled, and I literally just cut off all of my network. What does HA do? I'm sorry, I can't hear you. Yeah. And it's not cool when it happens 12 hours before the show starts, I can tell you that. All right. So anyways, what got us back online was the fact that we have an architecture such that permits me to find my stuff quickly. The important stuff, management cluster. Then we divide it out into compute clusters, okay? Compute clusters are basically what all the labs are running on, being controlled by the management vertical. Okay, so the management cluster houses all my lab managers, my virtual centers, okay? So each vertical, each stack you see up there, each compute rack has an associated lab manager and vCenter, okay? And on top of that, we're also running out the Active Directory. We've got one of the other things we learned, organization. I've got 5/24 subnets, okay? Because I had staging area 1, Cambridge, Massachusetts, staging area number 2, San Jose, okay? Actual on-site, Moscone, right? I have Verizon and I have Terramark, okay? And I have to keep track of several thousand at this point. I believe we have 5,000 mapped IP addresses throughout this environment, okay? Active Directory, love it, doesn't cut it, okay? I needed an IPAM solution, okay? So we went to Blue Cat. Blue Cat happily provided, just for me to say that sentence, Blue Cat happily provided me with an IPAM solution. So they were actually doing our DNS and our DHCP out of Blue Cat. Now, why that's important is because I got guys that need to assign gear fairly quickly, right? We're building 300 and some odd servers, 370 something ESX hosts. I want to be able to basically go out and map that out, have predefined, right? So that's what's running in the management cluster. IPAM, DNS, DHCP, all of the important stuff. The compute clusters I could really care about, right? Because after the management stuff's online, then we bring up the compute. Now, I need to access this stuff, okay? So if you're going to throw stuff in the cloud, how are you going to get to it? You're going to use RDP? Where is it? All right? How many people need to access it? What if you need to do stuff locally? What if you want to actually get into the environment, move stuff around inside the environment? Okay? Things you need to think about. So what we did was we built a view cluster. Right? I've got a couple of clusters available to me. I've got the one that's available for you, the student that comes in. We've locked down the desktops. We've wrapped it with security policies. Right? Made it so that you can get into the environment, but you can't harm my environment. Okay? That's not a challenge, but if you want, go ahead. Just we'll be talking at the end of the lab. But anyway, so I've got this view environment. I've got one for my management guys, the operations team. They have full-on, godlike powers to go anywhere they want inside this view environment. All the view desktops have all the tools that we need. Things like PuTTY, things like the VI client, things like PowerShell, all of the tools that you need to jump into a data center. Because guess what? You don't know whether or not your laptop is going to be accessible to that environment if you have a problem. So when you get into that environment, if you have to go to Verizon or you have to go to Terramark, you want to know that you have all the same tools, right? Tool sets are very important. Again, it comes to image, right? I want to be able to move images back and forth between the environments because I want to make sure, that I have that capability. I'm going to tell you, that was a big pain point for us. Moving data, right? It was okay to do it for the labs, have to carry the damn iOmega boxes, that's fine. But if I needed to change an image and I wanted to copy it from one data center to another, it was very, very painful. This is something that we have to solve as part of this cloud vision. We as VMware, we as in the industry, we have to solve this for you. Because I suffered from it. And I work in the industry. I didn't have a better solution. Right? And I didn't have the research. Not everybody can afford, an OC92. Okay? I just can't, nobody, and matter of fact, it's not even reasonable to expect someone to. So we got to figure out a better way, right? We just didn't have the luxury of time. I talked about that a little bit, right? The luxury of time is a problem. Now, if you have well planned and you know 2 months in advance, okay, how many here actually know 2 months in advance how much crap's going to change in their IT environment over the next 2 months? Nobody, right? We don't work that way. That's not how it happens. When you need to move a file in emergency, you need it, right? So for us, it was even worse, right? Because I had days, as I said, as opposed to weeks. So moving that stuff was a real pain point. We're working on it, but it's absolutely something that was glaringly obvious to me when we were doing this. It's a big problem. Now, so I've got my view cluster, my management cluster. Obviously, my racks are individually controlled. Each data center has 4 virtual centers. Okay, primary virtual center that functions as not only my management cluster and managing all the main clusters, but also manages all of the devices that manage the other devices. Meaning that if you look at the actual stack, VC houses all of the other vCenter 02, 3, and 4 are following under his management purview. However, they're still vCenters, so I link them all together so I have a single pane of glass. Okay? I had to deploy a lot of ESXos. Okay? Another little complaint of mine, and I've complained about it to VMware numerous occasions, bare metal provisioning. Okay? We leveraged the tools that came with a lot of the tools. Companies like Zego had some automation that they could throw at us. Cisco using some of their bare metal provisioning capabilities. But the fact of the matter is I told VMware we need to have a bare metal provisioning device, way to do it. But we leveraged the other tools. Okay, we did do Pixie Boot. Okay, scripted installs, and then we took host update utility and we used Update Manager to actually upgrade because we had these on 4.0 before 4.1 came out. We used Update Manager to update them. We used absolutely used host profiles. Host profiles, one of the other things you need to understand, continuity. I don't mean business continuity. I mean continuity in naming styles. I mean having standards. I mean having continuity between Site A and Site B. Right? If you log into Site B and it's called VC, and you log into Site A and it's called vCenter 01, you see what I'm saying? Continuity. What was the other thing? Finding out where we were in the environment. Where am I working? Type in, if it's code, having good naming policies, right? I mean, you think this is funny. I see some of you laughing at me like, well, that's kind of stupid. Why are you talking to me about naming conventions? I'm talking to you about naming conventions because when you start going multi-site, you start going out into the cloud, you need to know where you're at. Because it's kind of like, anybody stay at a courtyard, right? Up until recently, courtyards looked exactly the same. I could go to Peoria, Illinois, stay in a courtyard, wake up and see the exact same painting that I saw in Arkansas. And when you travel enough, and you wake up in a courtyard that's got the exact same painting, eventually you question your sanity and you wonder where the hell you are. Not that that's ever happened to me, but seriously, you telnet into a device. If it doesn't say VE, if it doesn't say MO or TR in front of it, how do I know I'm in Terramark? How do I know you know what I'm saying? Naming conventions. Again, change control, naming. I mean, these are all things that we're going to butt up into. Right? Lessons. Take my lessons to heart. When you start talking about this many devices, this many things going on, it's very important. Now, this particular rack right here, let's see. Rack 01 and Rack 02 are Cisco UCS chassis. Okay? The second rack, anybody tell me what compute Rack 03 and Rack 04 might be? Anyone? Just by identifying the profile? Yeah. HP C7000s. We got 12 half-height blades, 2 full-height blades in every chassis. And the ones that are blue are my management. Now notice, I haven't basically put myself into a position, okay, of having my management cluster sitting all in one rack or all in one chassis, right? So I'm cross-chassis, cross-rack. I did that again for a very specific reason. Because when John goes in and unplugs the top of rack switch, right, at least I know that something might continue to work on the rest of the actual management cluster, okay? So you'll notice that was Miami. Ashburn, same thing, okay? Same exact configuration. UCS chassis, HP chassis. Storage is NetApp and EMC, as well as I've got some left-hand networks. HP left-hand networks appliances, okay? And then we get to Beagle, which is our local data center here in Moscone. Called it Beagle. I have no idea why. There was a reason I made it up, and I couldn't remember what it was. But that's actually our core cloud. That's actually the core that's here in this facility, okay? This is running whitebox, basically MDS Supermicro Quad Vs. With the Zigo solution, Mellanox, and the Virtual I/O stuff, okay? And again, hitting EMC and NetApp storage in the back end, all right? Again, clusters layout exactly. Notice there's a continuity to these slides, right? Short of the actual way that the blades are actually spread out through the rack, but there is a continuity. You notice the similarity. That similarity is very important for us. Again, because of the whole courtyard thing, right? So, now, sponsors, thank you. Again, we already gave them lots of love, so we'll go ahead and take some questions. Yes, sir. Which product? Well, not unless they change it in the last 24 hours. I think it's still alpha. We're calling it tested. We tested it. It works pretty good. It's an awesome product. I mean, that's hella cool, man. PSTO-IP, encrypted streams over the internet, direct to a security server. It's basically a view server with this overlay on it that basically accepts PSTO-IP gateway connections. What the upper limit is, I don't know. I know we're running 120 on it. They've told me that, they've simulated, they've done actual 2, simulated like 1,200 per, but I don't know what's going to happen with it. Yes? Always a good question. What are the data stores? They're all of it. Right? We're running a majority NFS. As I told you, the backbone is 10 gig, right? Everything I've got in these racks is 10 gig. External to the racks or external to each data center, obviously slower connections. But actually, if you look at the floor, you walk into the lab room floor, it's a little bit overkill because these are PCO-IP thin clients. But at each pole, in an X fashion, I've got stacks of 3750s. They're looped up into each other. And there's a 10 gig fiber feed that runs from the actual pole back into. So every 120 units basically has 3 3750s with a 10 gig pipe going back into the actual data center. And oh, by the way, if somebody goes in with a pair of scissors and cuts my fiber, I have 2 other fiber routes going back to from the same stack, so I can basically just plug in another fiber if I lose a fiber connection. So that being said, I'm on a 10 gig network. And it's my opinion, and the opinion of many others at this point, that NFS and iSCSI are as equally capable as protocols now for us in the data center as fiber channel. Okay? Interestingly enough, right, with converged networking coming down the pipe to us, these things make more sense. What it comes down to is spindles. RPMs and spindles, okay? Or no spindles. When the cost for EFDs or, SSD devices come down significantly, I mean, look, let's be honest. I can get IOPS out. I can get 1,200 plus IOPS, out of a 200 gig SSD, which is pretty significant. Now, the cost per gig is significantly higher, obviously, but it comes down to IOPS for us, spindle speed IOPS. We've got SATA, we've got fiber channel, we've got NFS, we've got iSCSI. We focus on NFS at this point, mainly because of a lab manager limitation. We need to have NFS. I can only present so many LUNs to a lab manager instance to manage, but I can present a larger NFS volume to that than I can a fiber channel volume. It manages it better, handles it better. So we prefer NFS. Yes, we are absolutely running dedupe. And it helps. We're running dedupe, as much as we can across the environment. We are absolutely running PAM modules on the NetApps. All right. Yes, sir. Yeah, so that's outside of the purview of normal lab manager operations. For what we're doing with nested ESX, everybody familiar with the term nested ESX? All right, so I talk about this, and usually the big black hole space-time continuum thing starts to open up, and people, they explode, and it just, little heads exploding all over the room, it just gets kind of messy. But, so, it's not supported. That's why we do it. Much like you. We have what we call multiple layers of virtualization. There's like virtualization, and then there's virtualization, and then there's virtualization. Okay? And that means I can take an ESX host, and I can run an ESX host as a VM, and then I can run a VM inside of that ESX host as a VM. Okay? So what we refer to as ESX, VESX, VVMs. I see heads starting to swell a little bit. So the problem is we don't talk about this a lot because it's very hard. When you start getting into multiple layers, you start getting into complexities that go beyond normal everyday comprehension. Things like, what do you do with promiscuous networking? How do you set up a DVS in a virtual ESX host environment when you're actually already virtualizing the network stack? How do you run 64-bit applications when you've already virtualized the CPU that's 64-bit that's supposed to be 64-bit? Right, see, now you're starting to get it. Complex. One of the things that we have to deal with in Lab Manager, as far as it doesn't go to normal people, some of the things that we have to do, the way that we have to deploy some of these things, we have to be on NFS. I'm not saying that Lab Manager can't use it the way we use it. So you can go out and use fiber channel drives all day long. Fiber channel LUNs, you can go out and set up a SAN all day long. We need bigger, better, because we have to stack. Like we're using link clones. Everybody familiar with link clones? Right? It's one of the reasons why when you sit down at a lab, right, that it's there waiting for you. Well, actually, that's not the entire reason. It's when you sit down at a lab and if you have to sit there for 2 or 3 minutes, it's because we're doing a link clone deploy of your lab. If you have to wait no time, it's because Curtis and Claire wrote in this application called Prepop. And based on our kind of looking at traffic, we can tell what popular labs are, and we can try to stay ahead of the curve by having 2 or 3 of them pre-populated at any time. So when you sit down at a lab, you sit there and boom, all of a sudden your lab comes up. If it says, please wait, we're deploying your lab, you only have to wait 3 or 4 minutes because we're actually doing a link clone deploy right then and there. And the reason why we have that ability is because we're link cloning on a base disk, right? So every one of these labs is sitting on its own LUN, but it's deploying out X number of link clones. Okay? It's kind of hard to. And if you're not familiar with it, don't get your head wrapped too hard around that. All right? Some of my limitations are not your limitations. Okay? Any questions? How are we load balancing the labs? We have 12 virtual centers and 12 lab managers. And as part of the lab cloud application, we basically pick where we intelligently want to place your lab in what queue. So we find the lab manager that's not stacked too full. We have weightings on the labs. So some labs are really, really heavy weighted, meaning I can't have like a number 8 with 3 other number 8s because it would crush the box. So I might be able to have a number 8 and a couple of number 2s. And so lab manager in the application, working with lab manager and understanding what's going on, is intelligently trying to place across these lab managers how this works. Now, this might sound a little familiar. The reason why it might sound a little familiar is because if you look at the constructs of VCD coming down the pipe, he talked about things like, provider VDCs and organization VDCs. Well, consider this to be each lab manager is a VDC, right? And we're deploying based on load that I need to understand across each org VDC. Okay? Make sense? And someday, Redwood will actually, whatever the hell it's called, VCD, will actually have that capability, we hope, that we can actually move VCD in place of lab manager, and we'll use that instead to interface lab cloud to. Other questions? Yes, sir.
You talked about all the VMs being created. There's obviously a lot of disk I/O. You said lots of spindles. Are you doing anything special? Do vendors either give lots and lots of spindles, short stroking, doing anything like that to deal with that I/O?
We're very cognizant of I/O load. We think we have a stack out there that's misbehaving. Right now, quite frankly, the load that we're seeing, 20%, 30% on the NetApps and the EMCs. It's pretty standard. We're just smarter about the link clones. There's not a lot changing, right? When it happens, when you start seeing a lot of changes, that's when you start seeing a lot of block diffs going on down to the actual drives. But we've spread pretty wide. I mean, we've got, like I said, I do have some SSDs. I have a tray of SSDs, pretty much in each one. We're using PAM modules to the gentleman's earlier, right? We're using PAM modules that help offload some of the write caching and all that. We're using the EMC fast cache technology. We're trying to stay away from the SATA drives, even with, we're trying to stay on fiber channel and SSDs mainly because the SATA drives are still, they're still SATA. I mean, there's lots of them, but they're still kind of, it's 7,500 spindle speed, I mean, they're 1 terabyte drives, just like, great for archival purposes when you want to do this, but if I want to do this, I need to be on SSDs and fiber channel. The fast cache helps a little bit in front of the SATAs, but they damn sure helps a lot in the fiber channel. So it's kind of 6 of 1, half of the dozen. So our IOPS are, we pay attention to it. They didn't give us anything like there's no magic bullet. And that's going to be a problem for everybody out there, right? In cloud, right? Understanding data movement and data storage, right? What you want to put out there. That's going to be the dollar figure, in my opinion. That's the big thing for the cloud. And dedupe absolutely helps. Don't kid yourself. I've got customers that are running 60, 70% dedupe. Okay, I mean it's monstrous. So it's coming. Yes, sir. So, so it's hard to do that. It's a global thing for the array. So the SSDs are global. Once you set up fast cache, and I'm sure EMC would be happy to explain the technology behind it, but my understanding is once you set up the fast cache, they become much more or less they're in front of everything. Okay, and so it's one of those deals where some of the new HSM applications would help us if we were, let's just say we were going to stand this up forever. I was going to leave this in place for a year so you guys could go home and actually log in and buy lab time or stick time with us, right? If I were to actually do that, I would have something like the underpinnings of HSM, okay, that would actually shuffle things around. One of the problems that we're seeing is Lab Manager is, as you guys may or may not know, is an end-of-life product, okay? And so it's coming to its end. And the new storage technologies keep coming out, and whether or not we can continue to do what we're doing with Lab Manager is suspect in my mind. So we'll see. But we're leveraging as best we can, but it's usually SSDs are typically for the whole array, from what we've been told. So yes, sir.
Lab Manager coming in, what's next?
They announced it. VCD, Cloud Director. There's a path to get from one to the other, but you didn't hear me use the term upgrade. Are you a Lab Manager customer?
Yes.
You need to talk to the guys down at the booth. I'm going to explain it to you. I'm not a Lab Manager guy, so I can't tell you, but I can tell you that, yes, sir.
Okay, so, 6 months before this event happened, somebody walks and says, we're expecting 16,000 people at this event. How do you even plan to concept tomorrow?
Well, so we started planning the day I left. The concept was I had two options to me last year when I left. After watching the time-lapse photography of the build of the actual data center, I was just like, it was it. I quit. I'm done. I'm not doing this anymore. Our goal is always to. The challenge is this, all right? We had instructor-led labs last year, right? 11 of them, I think, right? And then we had 200 stations of kind of self-paced labs, and we had 20 or so labs in there. The challenge has always been, back when we were 1,200 people, getting 1,200 people through 11 instructor-led labs, because you had 4 days to do, sessions of, 45 or 48 apiece, it wasn't too hard. When you get to numbers like 17,000 people coming to a show, you have to kind of draw a line in the sand and say, I can deliver so much, right? I mean, there always is. It's funny. You look down there now, and we got empty seats, right? And people are always complaining, not enough lab time, not enough stick time. Well, I can tell you right now, this year, you should be able to get lab time. We're open from 8 a.m. until 10 p.m. last night and yesterday and today. Okay, the hours are insane. You should be able to get in there. To answer your question, how do we plan for it? There's never enough. Marketing people always want more. If you really want to know the truth is the amount of effort and money, it is literally 1,000, based on what I've calculated alone, based on the gear that we've got and the time that we put in, is $1,000 a head to put on these labs. And that's based on 15,000 people showing up. All right, so that's $1,000 a head that we're putting out. I mean, granted, equipment's donated, and when you start pulling back, but if you look at the actual cost, if you were to stand this up, but then if you were to stand this up, look at the amount of hours, how many VMs did we deploy, right? So it's kind of to do that planning, it literally starts the day that this is not my full-time job. This is my full-time job for 2 months. The rest of it's to help make VMware's products better, work with product management, with engineering. But these are big lessons, right? This is not like throwaway. Right? What we do here is very important, not just for you, but for us, to understand some of the, but what I don't have a lot of is like, the operational side of things. Because standing up a lot of these operational tools takes time, and it's like trending, and I have 4 days. I manage a huge, Fortune 500 size data center space for 4 days, right? So,
How big was your team?
So the Ghetto team, Global Engineering Technical Operations team, that would be my team. All right. The Ghetto guys is a team of 8. We pretty much handle most of the infrastructure. Now, I don't want to take anything away from Claire and Curtis, the core lab team, several management folks. We've got Mary, so one of our project managers. She actually project manages, keeps us all in line. So that's about 10 on the core, 10 or 11 on the core team. Okay. And then, you got 150 what we call lab captains and proctors running the floor. 60 guys that focused on the content for lab. The content was started and developed in January. Okay, and we've updated, we've used it for several other events, and we've updated as we get closer to this. So all told, the effort to put on the labs is somewhere in the area of 175 to 180 people. But the actual standing of the gear, that's one of the things that's the other thing. So when we did the instructor-led labs, we basically had the instructors, and they had like a technical operations group. We basically said, here's 2 tech ops guys, 4 of your lab guys, 2 tech ops guys. Go stand up your own like little 2 racks of gear, and you had to do that. 5 minutes? Thank you. So this year, when I had the bright idea to say, I got to do something better than last year. That was kind of how this rolled in this conversation was. I saw the video and I was like, man, that is way cool. So I either got to quit this and go do something completely different and not even pay attention to VMworld Labs next year, or I got to come up with something better because you guys always expect the wow factor, right? So we decided to double the stations and get away from instructor-led labs. And we took, and I knew that was going to be a bit of a shock for some of you because some of you like to have that interaction with the instructors. So, what was that? Especially me. Thanks. See, I love you guys. So that interaction I feel is very important and giving you that ability. So we picked 10, and that's what these advanced sessions are. Literally for you to either go take the labs, develop questions in your mind, come up here and have an interaction and stand up and ask questions, or go take the advanced session and go screw around with some of the stuff nobody says you have to mess around with the lab manual and actually do the step by step. We have this one lab that we were originally calling it the kitchen sink. It's pretty cool. We crammed as many of our products in one lab as you could, and it's literally just, hey, this is here, this is here, this is here. We got like SRM, Heartbeat, vShield Edge, Zone, all of these products crammed into this one thing, just so you can actually kind of see them interacting together. It's really not a lab per se. It's literally like a point, and it's like an introduction of, hey, here's everything all together. Go, just sit down for an hour and muck around through the environment, right? And so to make up the difference between not having the instructor-leds, we basically provided several hundred hours of interaction with the actual subject matter experts up here. So we either take the class first or take the advanced thing first, then go play around, or go play around and then come up with your questions. Yes, sir? All of my slides will be available somewhere. Wherever the other slides are available. Ask somebody else where their slides are available. Mine will be there too. I don't know what to do. I'm pretty sure they're posting them on the web. So, yes, sir. Yeah, they're tracking it. They walk into the data center and they go, hey, how's it going? It's good. We're going tracking around 20%. Yep, awesome, great, walking away. Again, to set that kind of infrastructure up, it takes so much time. We're only here for 4 days, And I need to focus on my stuff. And the problem is when the vendors come in and they want to start setting that stuff up, it tends to take away from what I need to focus on to deliver you guys labs. So, 5 terabytes. I can't begin to. It's a lot. I mean, we've got. So you don't see there's no ice reservation. Not on an NFS volume, no. Yeah, it's out there. Hey, oh yeah, you want to see the video of the build? Go to. It's on YouTube. Do VMworld 2009, and it says "Building of the VMworld Data Center." It's awesome. It's got a great little soundtrack, and it gives all of the stats of the data center. It's awesome. It's me. It's me in it. There's a couple of interviews with me out there, too, if you want to see those.
And at the end of the day, I'm going to fall over. How do you feel about
Yeah, that one. Yeah. Yes. Thank you, folks. I appreciate it.